All right, 7.5 and 7.6 factoring, and I actually teach these two lessons together because 7.5 deals with quadratic without a, or when a is 1. 7.6 deals with quadratics when you have a. I just find it easier to teach them all together at the same time. So when we're factoring, first thing to recognize is really what our goal is. Our goal is to take a trinomial or a polynomial and put it in a situation where you're multiplying two things together. So you have parentheses, okay? That's kind of the visual you're looking for, is a set times a set, or something times a set. You're trying to find the product of two things versus having the sum of multiple things. Okay. And then once we get there, we'll actually take it one step further and we'll set these sets equal to 0 and solve. Okay, but our goal today, or at least for these first few slides, is to get it so that we can actually factor. And the process I'm going to show you will actually work for all of these forms. There's 3 different forms you see here. You have standard form ax squared plus bx plus c, where b is positive and c is positive. You have standard form ax squared minus bx plus c, where b is negative and c is positive. You have the same thing, but when c is negative, and then you have the same situation where b and c are both negative. Okay, but if you follow the process I'm going to go through, then all of these work out the same way. Okay, so we're going to factor each of these forms, and I'm going to walk you through the steps that we're going to do as we go through it. Okay, so as long as we're in standard form ax squared and bx and c, then we can go through this process. So step number 1 is to always look at your quadratic and try to find a greatest common factor. Okay, so in other words, is there something that goes into 3, 5, and 2, or 3x squared plus 5x plus 2? In this case, there isn't, but sometimes there is, and that you'll want to factor out, and we'll actually see that here a little later. Okay, but if there is nothing, we're going to go on to step 2. In step 2, I'm going to show you this visual here, and then I'll explain it with the first problem. You're going to take and you're going to identify A and C, and you're going to multiply A times C. And you're going to put it in that little X here. There's like 4 positions you're going to fill out, these 4 positions. So up here we have A times C. And A times C happens to be in this problem 3 times 2, or 6. Okay? And then down below here, in this spot, we're going to put B. Okay, so in this problem, B is 5. So we're just going to put the 5. We don't worry about any of the X's or anything. Okay, and so now we have these 2 numbers off to the side here. We're going to have this number, and we're going to have this number. And these 2 numbers, what's going to happen is we're going to try to find 2 numbers that multiply to make A times C. Okay. And then add to make B. Okay, so they want them to, these 2 numbers have to multiply to make A times C and add to B. So in other words, in our problem here, we need 2 numbers that will multiply to make 6, but add to make 5. That is the goal of these 2 numbers. And so whenever you hear about the diamond method, this is kind of the diamond method. So 2 things that multiply to make 6, but add to 5. And if you struggle with this, then just list out your factors of 6, right? Like 1 times 6. Do those add to make 5? No. 2 times 3. Do those add to make 5? Yeah. So we'll put 2 and 3. Okay? That's step 2. Step 3, let's go ahead and switch colors back here. Step 3 is just to set up your parentheses. And what you're going to put in your parentheses is X, or whatever variable you're using. If you're using T, put T. If you're using Y, put Y. And then you're going to put in whatever numbers you had here. So if it's a positive number, you put plus that number. If it's a negative number, you put minus that number. But we're going to, I'm just going to put plus those numbers right now because they're both positive. So I'm going to have plus 2 and plus 3. Okay, so these numbers just get filled in there. That's step 3. Step 4, Step 4 is to take those numbers, whatever you have back there, and you'll notice I've kind of put it up there a bit. I'll show you why. You're going to take those numbers and you are going to divide by A, whatever your A term is. So in this case, our A term is 3. So I'm going to divide by 3. Okay. Next step, step 5, is you want to reduce. Reduce whatever your numbers are. Reduce your number over A. Okay, so whatever your number divided by A was up here, reduce it. In fact, let's use that same color. So for those of us that are color coordinated, I'm colorblind, so it doesn't matter to me all that much, but reduce those numbers if you can. Okay, so when I'm looking at this, I'm looking at 2/3. Does 2/3 reduce? It doesn't, so I just leave it as 2/3. Does 3/3 reduce? Yeah, 3/3 becomes 1, right? 1 over 1. So just 1 divided by 1 is 1. And you're one step away. The last step, oops, that's anticlimactic there. Unbelievable. The last step, number 6, is to take whatever you have in a numerator and denominator. You're going to have a numerator and denominator left back there. So you have x plus your numerator over your denominator. So notice I have a fraction right here. You're going to take whatever denominators are left and move them out in front of the x. And actually that looks like it's outside of the parenthesis. It's not outside the parenthesis. Okay? Take whatever denominator you have and move it outside in front of x. So this 3 moves right out here in front of x. So it becomes 3x plus 2. And the x plus 1 doesn't have a denominator other than 1. It just stays x plus 1. And you have now factored it. You can double check it, right? I mean, 3x times x is 3x squared. 3x times 1 is 3x. 2 times x is 2x. That's 5x. And 2 times 1 is 2. You factored it. And really, it doesn't matter. You can write it like that, or you could write it like this. The order does not matter. You can multiply in any order. So either of those will work. All right. Now, those steps are the same for every type of problem. Let's work through this one right here. Ax squared minus bx plus c. What I would do in class is I'd say, okay, try that problem, get as far as you can, and once you're stuck, let's go through it. So right here, use a good time to pause and try that. Okay, so I'm going to do the first step. Can I take out a greatest common factor? No, nothing goes into 2x squared, 11x, and 5. Okay, so I'm now going to go to my x there. Two things that multiply to make 2 times 5 are 10, and add to make a negative 11. When I think of my factors of 10, that would be like 1 times 10. Those add to make those add to 11. So if I can make, maybe if I go negative 1 and negative 10, now I have negative 11, and negative times negative is positive, so that works. These two multiply to make positive 10, negative times negative, and negative plus negative add to negative 11. Okay? And so I set up my parentheses now. I have x minus 1, x minus 10. I'm now here. I divide by a. A is 2. Divide by 2, divide by 2. I have x minus 1/2. And x minus, well, I have to reduce. 10 divided by 2 is 5. Okay? And then I'm going to go ahead and pull this out in front. So I have 2x minus 1 and x minus 5. And there we got it. I have now factored it. Okay, let's try another one here. And if you have questions, I would just list them and ask your teacher tomorrow. But I look at this one and I try to find a greatest common factor, and I recognize there's not even a number here. If you don't see a number, then it's 1. So what I'm looking for here, I'm looking for two things that multiply to make negative 30. 6 times negative 5, that's a negative 5. Negative 30, and add to positive 1. Okay. When I think negative 30, that means if I'm multiplying to make negative, one of these two things need to be negative. Okay. So what I could do is start thinking of 30. Well, if 1's going to be negative, that means I'm going to actually kind of be subtracting them. Like 1 times 30, well, those differ by 29. That's not going to work. I need to make 1. 2 times 15, well, those differ by 13. 3 times 10, well, that differs by 7. Then I have 6 times 5, right? Well, 6 times 5 is a pretty good set there. If I do 6 times 5, and I've kind of scrunched myself here, so I'm going to move this down just a bit. So that's a positive 1. Okay, if I go 6 times 5, that makes 30. Negative 6 times positive 5 gives me negative 1. So if I make 5 negative, I now have negative 30 and positive 1. Negative 6 or negative 5 plus 6 is 1. Negative 5 times 6 is negative 30. So where we've got it, we've got x minus 5, x plus 6. We divide by a. Don't forget to divide by a. That's something you'll start doing. You'll start forgetting there. So I can't reduce 5 6, but I can reduce 6 6. 6 6 reduces to 1. The 6 moves out in front, so I get 6x minus 5 and x plus 1. And remember, you can put them in either order. You can put the x plus 1 first if you wanted. By the way, these sets are called quantities. And quantities, say the quantity 6x minus 5 times the quantity x plus 1. Okay, one more here. So two things that multiply to make, looks like 5 and negative 7, negative 35. Add to make negative 2. Okay, so if you struggle, remember, just off to the side, list what you're trying to make. It's a negative, so you're kind of like finding the difference between them. So two things that differ by 2. 1 and 35 don't work. 2 doesn't even go into it. 3 doesn't go into it. 4, notice I'm trying to do it orderly. It doesn't work. 5 and 7. Okay, those differ by 2, and I need negative 2. One of them has to be negative. So since I have negative 2 down here, I have to have negative 7 by 5. Negative times positive is negative. Negative plus positive. Well, I have more negatives, so I have negative 2 there. So I have x minus 7. Oops. X plus 5. I then divide by a. Divide by 5. I have x minus 7/5 and x plus 1. 5/5 reduced to 1. I move this out in front. 5x minus 7 and x plus 1. There we got it. All right, well, let's go ahead and try some others. Now, I don't have the steps there, and I'm not going to rewrite them, so I hope you have them in front of you still. First step. Well, if you pause this, hopefully you'll pause it and try it. If you're in class, I'd say, okay, first step, and most students would forget to check for the greatest common factor. What goes into 4, 20, and 44? Well, 4 does. 4 times what is 4x squared? That would be x squared. 4 times what is 20x? That would be 5x. 4 times what is negative 44? That would be negative 11. Okay? Then once you're done there, really the piece that you're looking at is this. We've already taken a 4 out. The 4 just kind of tags along with us from now on. We're looking at the x squared plus 5x minus 11. And what you want to do now is you want to see if you can factor that thing. So two things, like I said, ignore right now, ignore the 4. Two things that multiply to make 1 times negative 11, and add to 5. Well, there's only two things that multiply to make 11, and it's 1 and 11, and they don't add to 5. So that means you cannot factor this. There's nothing. You can't factor any further. So, that means your answer is what we had there. You took out the 4 and that's it. There we go. All done. Okay, let's try another one here. If we look at this here, look for the greatest common factor. So that'd be 7. 7 times what is 7x squared? Be x squared. 7 times what is 21x? 3x. 7 times what is 14? 2. Okay? And then focus in on this piece right here. Okay, ignore the 7 for now. Okay? So you're looking for, whoa, yeah, that's kind of a cool looking x. We'll leave it like that. Okay, but I'm going to go ahead and change colors here. 2 things that multiply to make 1 by 2 or 2 and add to 3. Well, that'd be 1 and 2, right? 1 times 2 is 2, and 1 plus 2 is 3. So this becomes, the highlighted there becomes x plus 1 times x plus 2, and then the 7, like I said, it just kind of tags along there. Right? You are now done factoring. You can't you could divide by a, but a is 1. But when you divide by 1, nothing happens. So if you ever have a 1 out here in front, really 1 times 2 is 2. That's just that number. And when you divide by a, when you divide by 1, 1 divided by 1 is 1, and 2 divided by 1 is 2. So really, when you divide by 1, nothing happens. So you just leave it. You kind of like it when a is 1. All right. Well, let's go on to our final step, which is solving these. Notice now it doesn't say factor, it says solve the equation. We can only solve when you have an equal sign. Okay? That tells us we can solve. And what you're looking for is to have it equal 0. You want it in this format, ax squared plus bx plus c. Now it doesn't matter what the signs are there, but it has to say equals 0. It has to say equals 0. I can't emphasize it enough. It doesn't say equal, ooh, that's not the color I wanted. If it does not say equals 0, then we're going to have some issues. Okay? You're going to get frustrated. So make sure it says equals 0. So I look at this first one, 11x or x squared minus 11x plus 24 equals 0. This next one says equals 6. This one says equals 3. We're going to have to deal with those. The first one, we're good. It equals 0. We just look at factoring. Okay, can we take out a greatest common factor? Nope. Nothing goes into those. So 1 times 24 is 24. 2 things to multiply to make 24 add to negative 11. Well, if you know your factors, 1 and 24 don't work. 2 and 12 doesn't work. 3 and 8 does work. Okay, negative 3 times negative 8. Right? Those negative times negative is positive. Negative plus negative is negative. So I get x minus 3 and x minus 8. And that equals 0. Okay, now I've got to solve though. I've got to go one step further. So if this quantity times the quantity x minus 3 times quantity x minus 8 equals 0, one of these two sets has to be 0. So that means either x minus 3 equals 0 or x minus 8 equals 0. X minus 3 equals 0, x would have to be 3. And when x minus 8 equals 0, x has to be 8. So my solutions are x equals 3 and x equals 8. Or x equals the set 3 and 8. There we got it. So either one of those answers. It depends if your teacher wants it in set notation. Okay, this next one actually is having us, well, we've got it set it equal to 0 first. Let's move the 6 over. So I'm going to subtract 6 from both sides. So now I have 6x squared minus 18x, and negative 18 minus 6 is negative 24, equals 0. Now I've got it equal to 0. Next step. Yep, oops. Look for the greatest common factor. 6, 18, and 24, 6 goes into. 6 times what is 6x squared? That's x squared. 6 times what's negative 8? That should be negative 18x. Okay, well that would be minus 3x. And 6 times what's negative 24? That's negative 4. And now we are going to focus on factoring this piece. Okay? So 2 things that multiply to make negative 4 and add to negative 3. Okay, they multiply to make negative 4 and add to negative 3. I really am having a hard time writing that negative 3. There we go. Okay, well, you think of your factors of negative 4. If it has to make negative, one of those two things has to be negative. So negative 1 times negative 4, or positive 4, that makes positive 3. So how about negative 4 times positive 1? That's negative 4, and that's negative 3. Okay, so we'd have our set would become x minus 4, x plus 1, and then the 6 just kind of tags along with us. All that equals 0. Okay? That means either 6 has to equal 0, which is impossible, or x minus 4 has to equal 0, which would mean x would equal 4, or x plus 1 has to equal 0, which means x is negative 1. Okay? Those are my solutions. The 6 doesn't do anything for our solutions. So x equals 4 and negative 1, you could write it like this. It doesn't matter the order. Usually you go numerical, so negative 1 and 4, but either one of those is fine. Okay. Last one here is we are going to go ahead and set it equal to 0. So we're going to go ahead and move that 3 over. So we have 7x squared minus 6x, that's 0, equals 0. So now you're looking at it, and it's kind of weird. Now I've had some students in class actually put the 0 in here, and they do this whole thing. They go, well, 7 times 0 is 0, trying to make negative 6, so that is, well, negative 6 and 0. And then they do the sets. They say, well, it's x minus 6 and x plus 0, and divide by 7, and I get 7x minus 6 and x plus 0, which is just x. Okay, that works. It takes a while, but that works. I wouldn't do that, but it does work. What I would do is I just look for the greatest common factor first. What goes into 7x squared and 6x? Well, 7 and 6, nothing, but x squared and x is just x. X times what is 7x squared? Well, that's 7x. X times what's negative 6x? Well, negative 6. And you'll notice this right here is the same as this right here. These two pieces are the same. Okay? So let me actually highlight that just so you know. And you could do it either way. Whoa, wrong highlighter, man. Shee-me. All right, let's try that. There we go. You do it either way. They're the same thing. I would prefer using the greatest common factor like I did. That's why I did that. Okay, but from here, notice there's an x on the outside now. So now we have to pay attention. Over here, it was 6. There was no x, so we didn't have to pay attention. So that means that piece could be, it's a variable. It could be 0. So that's one of our answers. And then we have this piece right here, 7x minus 6. Could equal 0. And if that's the case, we add 6, 7x equals 6, and then we divide by 7. X equals 6 over 7. Leave it as a fraction. So those are your solutions right there. If we write it in set notation, that's 0 and 6, 7. All right. Well, I think that's all I've got for you. Let's check. Yep, good lucky.